Okay, so hello and welcome to another of our FME educational webinars. This time our focus is on how FME can be utilised in the transportation sector. My name's David Eagle and I'm the FME Division Manager at OneSpatial, and I've got my camera on just to prove to you that I'm a real person, and I'm going to remove that now to avoid the distraction. There we go. I'm also joined in today's session by my colleague Charlie Doherty, who's available in the session and will be monitoring the chat function should you have any questions you'd like to send our way. As usual, we'll do our best to deal with anything you might ask during the session, but if we can't deal with it quickly, we'll follow up with you straight afterwards if you leave us some contact details. So here's the agenda for today. After a brief introduction to who OneSpatial are, just in case this is your first time with us, we'll get straight into the focus for the session, which is what we see as common themes across the transport discipline with respect to data. That includes prevalence of standards, challenges moving data between CAD and GIS systems, as well as proprietary systems like transport modelling tools, a requirement for base mapping and connectivity to web services of all kinds. Then, in the context of different modes of public and private transportation, we'll take a look at some of the ways that you can utilise FME to make things quicker, simpler and more efficient for you and your project teams. Now, as I said, if it's your first time with us, welcome. We're OneSpatial and our focus as a business is to help you to unlock the value of your data. We're keen to live in a smarter world, and we think that making your data smarter and of a greater quality is just one way in which we can all help ourselves to do that. We're a software development company in our own right, and we've been building software for 50 years to help manage our customers' data quality. But we recognise that there are other companies in our space that offer huge value in what they do that can complement our expertise. Over the years, we've selected a number of firms to work closely with, and the partnership that I intend to focus on today is our Platinum partnership with Safe Software, the makers of the FME platform. Safe are based in Vancouver in Canada, and we're a reseller partner in the UK, Australia and the US, with experts also in Ireland, France and Belgium. As a business, we focus our attention on three core vertical markets: government, utilities and transportation, with dedicated solutions in each. But we find that because FME enables data connectivity to all sorts of locations, databases and APIs, that almost any sector that finds it necessary to move or manipulate their data can get value from FME. The logos you see here are just some of the companies leveraging the power of FME to assist them. At OneSpatial, we build software and resell products built by a handful of other companies, but at our heart, we're a collection of consultants who help organisations to manage their data. We see a lot of transport-related data, whether it's on projects with local authorities, engineering companies or network operators, and there are some consistent themes that crop up time and again when we're working on the transportation projects. CAD to GIS data transformation is a really common theme in this sector, and the sector produces a lot of data from both CAD and GIS systems, both of which have areas in which they excel. That's why they exist. Commonly, this data has to be exchanged between multidisciplinary teams, and as the two types of data are very different, issues such as projection, attribution support, geographic tiling, precision, labelling and much more has to be handled. Importing and exporting data is also really important between proprietary systems, often from or to a standard, and a number of transport standards exists. The Department for Transport maintains the Trans-Exchange Standard, for example, the UK national standard for exchanging bus schedules and related data. It was devised over 20 years ago. It's built on the XML standard, and you can find out more at the address on the slide there. ATCO-SIF data was the precursor to Trans-Exchange, before it was modernised, but there's still a lot of this old data about too. TransLink in Northern Ireland updated their timetable data just last month, and it's available in ATCO-SIF format via data.gov.uk right now. There are lots of proprietary transport planning packages available too. For example, if you're interested in advanced traffic simulation software, then PTV Visim might be of interest to you. Take a look at ptvgroup.com. Arcady enables assessment of roundabout capacity and delay, whilst Picardy focuses on priority intersections, and both packages are available from TRL software. And those are just a handful of tools that deal with vehicle analysis on the road network. I've not even touched on multimodal interchanges or rail network capacity analytics. One of the things that dedicated packages like this have in common is a need to consume network and traffic data in a specific format. Often products like this need data preparing in a specific way, and they can only ingest the data in specific formats like AutoCAD's DXF or text and CSV, maybe XML, Excel, or some of the spatial formats like MIF MID and Shape. And you won't be surprised to know that FME is pretty good at prepping data into the right structure and format for these packages to consume. The other common theme in this sector is that generally location is really important. Whether it's a street sign, a lighting column, a marker post on the motorway, or some accident statistics, displaying transport-related data or reusing analysis generally involves or the resulting analysis from transport-related data generally involves some sort of base map. Whether you're planning the implications of a new rail route or on existing land parcels or dwellings, or you're measuring carriageway widths to identify the potential for shared use with cycles or pedestrians, you're likely to need a base map. In the UK, OpenStreetmap, found at openstreetmap.org, is a very rich source of map data, and of course we also have the Ordnance Survey, who produce some of the most detailed and feature-rich cartographic data in the world. It's also important to note that the OS are increasingly serving their data via web services and assorted formats and structures. And then there's accessing web-based data itself. We live in a time when many of us would find it hard to understand how we managed in our private lives without the internet. Let's face it, in the last 18 months, we've all consumed rather too much content from Netflix and Amazon Prime. Many of us have also had to become much more technically savvy, if only to help us manage all our passwords for the likes of Google Classrooms for homeschooling during the recent national lockdowns. Professionally anyway, many of our daily used tools have moved or are moving into the cloud. Whether this is our email or our documents, we're having to adapt to a new way of working with services and data not necessarily always traditionally stored on a local server like it once was. The transport sector is one where a lot of our data sources are coming from hosted services or APIs, all at the end of a URL. For example, we're currently engaging with a new rail project in the UK that requires us to get data out of their Bentley ProjectWise document management system hosted remotely, extract it, restructure it and load it into their cloud-hosted Oracle Spatial Common Data Environment, or CDE. This requirement is becoming the new normal. Anyway, as I mentioned, you won't be surprised that the reason for us to pick up on these themes is because in all cases FME has your back and can help you handle all of the data challenges. Let's have a look at what I mean with a few of these. Just to start with a little bit of context then, CAD to GIS scenarios crop up quite commonly in the rail industry. And since you'll no doubt have heard or be very familiar with CAD to GIS challenges, I'll start there. Infrastructure projects generally involve a lot of contractors and engineering firms. You only have to look at the hundreds of firms involved in HS2 or the more modest volume of contractors and partners working on the design and planning for the Lower Thames crossing for Highways England to see that keeping track of your data is vital, if only to avoid scope creep, delays or the overspend that can result. Managing the flow of the master data out of and back into the parent organisation is vital. Managing versioning, schema and ensuring errors don't creep into your data is especially important. In a challenge like this, FME has a role in accessing the data in the native format, transforming the schema and keeping the data flowing. We worked, for example, with Network Rail to design a system that allowed similar flexibility to this, where data could be checked out as a package, edited elsewhere, and then checked back in using a controlled workflow. This solution was in essence a CAD to GIS managed workflow, and in this case we actually coupled tools from the One Spatial Management Suite with some of the products that we resell, like FME and GeoCortex, which is another product that we resell from another Canadian firm. And these tools, used all together, allowed us to perform a complex data check-out and check-in procedure. A user defined the area, the extents that they wanted to check out using a web map interface in GeoCortex. The One Spatial Management Suite managed the job and requested that FME Server goes and performs the data extract. And then FME read from Oracle and wrote to MicroStation design files, mapping the data to the new schema in that CAD format. And then the return journey had the addition of change detection against the DGN using FME, and also our unique rules-based validation with OneValidate. So we had this complete round trip of data from start to finish. So now we've got a little bit of context. Who are Safe Software? Well, they've been around since 1993, and they're still actually owned by the two guys that founded the company back then, Don and Dale. The FME platform is an international product used by thousands of companies across the world, and the user community is extremely collaborative, and you'll struggle to find a more friendly bunch of technical users keen to help with your next data challenge. Lastly, the most important point to make is that FME future-proofs your project with its enormous catalogue of data format support. So if you care about data, or with or without geometry, FME can more than likely help you connect to it, transform it, and automate your process. And at One Spatial then, our FME division is wholly focused on helping our customers to get the best value from their investment in FME. We do that by first of all ensuring that FME is actually the best fit for you through product evaluation and the provision of demonstrations dedicated to your challenge. We also provide consultancy to help you build your automations, and if you prefer to do it yourself, we have a schedule of training classes that we can deliver online, or all being well, at some point soon, face to face. We also sell FME, and of course we can offer a number of different pricing structures and currencies to suit you. All of our software agreements also include maintenance and technical support to suit your needs. Back to the topic in hand then. An FME helps organisations in the transportation sector increase operational efficiency throughout the project lifecycle by integrating data across data containers, systems and software platforms, whether they're installed locally or in the cloud. This integration can streamline project workflows and making data accessible to the stakeholders that need it, where, when and how it's required, will improve engagement between partners and the end client. Data connectivity is really important then, because in order to extract useful information we have to be able to access the source data to be able to import it into the system that needs it. Data standards are common, and those standards control the way the data is structured. Now, out of the box, FME supports lots of data standards, and to find out a little bit more, be sure to hop over to our blog on and my article on FME's recent certification from the Open Geospatial Consortium at that shortened URL there. So that's bit.ly/FME_OGC. So the underscore is a little bit hidden there, but you can just about make that out. bit.ly/FME_OGC. That said though, if FME doesn't natively support your standard, it's often possible to create a process that can still consume your data. Often because your industry standard's likely built on top of another data standard that FME does support. Earlier on, for example, I mentioned that the TransExchange transport standard for exchanging bus schedules and related data. Well, FME doesn't support it as a standard reader, but because the structure is built on the XML standard, we can make FME read it. So let's first take a look at some example TransExchange XML and then open an FME workspace that parses it. So in order to do that, I'm going to take a look. Here's a little bit of this TransExchange data. So there's some metadata at the top, and then there's a tag that gives you a bit of detail here about a particular stop. We've got a stop type classification, so that's for buses and coaches on street. and it gives you a little bit of detail, and there's some X and Y coordinates in here as to the location of where that bus stop is, and you can see that there's a whole bunch of different stops included in this data set. But it's a text document, it's a document structure, it's not desperately useful from a visualization perspective. So what we're going to do is go and see if we can process this data using FME. So in order to do that, I'm going to just open up a little pre-configured FME workspace. Now this is slightly different to workspaces that you would see normally, partly because I've saved it out as a template document, and I've done that so that I can actually save something called caches in the template. So you'll see as soon as I open this up, I've actually got a workspace that's got these little green magnifying glasses, which is effectively cached data at each stage that allows me to take a look at the content. So I've got a workspace with some transformers in the middle of a reader and a writer. So I'm reading data from XML. That's the XML file I've just showed you, and I'm writing out to an Esri shape format, which is a spatial format. It's very common in the sort of GIS sector, and we're going to restructure the data a little bit so that rather than us having this document structure here where you just see XML, we're actually going to extract some information from it and create points on a map so that we can actually see them. So in this case, what we've got, if we take a look at our data a little bit, is need to just zoom to the full extent, and you can see here that I've got some little spots on the map. Those spots, if I just make them a little bit more visible by making them red and a little bit larger, you can see that these are the bus stops. So they were stored in the document structure in the XML, and I've just drawn them out and created points on a map to represent them. So they're in the West Midlands here, close to Cannock and Stafford, and we've also got some route sections. So the route sections, if I just join them up, you can see that I get a line that connects the dots effectively. So if I just go in to here, we can make those also a different color. Let's make them green, and we'll make them a little bit wider just so that you can see those. So that's the bus route itself that goes between each bus stop. So if we zoom in a little bit, you can see that the background map turns on. This is sort of a stylized version of OpenStreetmap in the background, more on that later. And you can see that we've got the green route that travels across it. So we've gone effectively from a text document to a spatial document, a spatial data set, and we've got tabular information tucked away in here, and the rest of the workspace really just tidies up the schema, the structure of the data, so that our column names are tidier and are uppercase, and we keep just the attributes that we care about wanting to export or from the XML format or import into our transport planning system. So that's our a little example of a process with respect to trans-exchange data. So, as many of you will know, there's also rather a lot of open data available on the web, and as part of a desk-based study for a transport-related project, it's often where we start, trawling the internet for all of the information we can get freely, simply and quickly from organisations, and more often than not from enthusiasts who've posted that data for anyone to use. We do this because actually going out and gathering data or contracting agents to get it for us is expensive. Just go and search for bus stops on data.gov.uk and you'll see what I mean. Plenty of content published for free, like the data from Plymouth City Council. Let's take a look at a really simple FME process that automates the downloading and processing of some bus stop data from Plymouth Council and load it into Google Earth to review. So if I just go and open up FME Workbench again, and I'm going to close down the process that I had open earlier on, and I've got a really simple workspace that I've written that effectively goes and connects to a GeoJSON dataset, but this GeoJSON dataset is actually stored online. It's at Plymouth's data place, and you can see there that I've effectively got access to a Plymouth bus stop locations GeoJSON file that's online. So if I always go to that data set that's online, I'm always going to get the current data. And all I'm doing really here is just making some labeling changes to the data so that when I write it out into Google Earth, that data set looks in a particular way when I visualize it in Google Earth. So if I run this process, it goes to the internet, it grabs 1,831 bus stops that are in Plymouth, downloads them, converts them into Google KML, and then if I go and open up the file that I've just produced, which is this file here, and double click on it, then it opens up in Google Earth, and you can see that now we've got rather a lot of bus stops that we can go and take a look at, and I can zoom in at a particular location, and we can see that I've found one on Crozier Road there, and the aerial imagery actually picks out the fact that it's a bus stop. So we've got the details there, and there's the classification type of the stop itself. Okay. Lastly then, when looking at data access and standards, I just wanted to touch on another type of standard, that of projection systems. Ensuring the precision of our spatial data is incredibly important. It can be the difference between avoiding or hitting buried infrastructure when we're digging up a carriageway, or ensuring that a corner on a rail track curves gently enough so as not to disturb your coffee on the table when travelling at high speed on a Pendolino train. FME supports thousands of coordinate systems such as British National Grid, Irish Grid, and assorted variations of latitude and longitude. But it can also be configured to support dedicated grids like the Heathrow local grid or London Survey grid, commonly used by TfL and Crossrail, or Snake grid, used in long linear schemes like High Speed 2. And just on that last point, there's a plugin called the Snake Grid reprojector that was devised by Jonathan Iliff of UCL. And if you're interested in the plugin, we can supply it. Or you can also go and take a look at the session that Jonathan presented for us recently if you'd like to find out more about what Snake Grid is technically. You can find that session at bit.ly/FME_snakegrid. When it comes to base maps, globally there are lots of providers, and I'm just going to touch on two of them here, OpenStreetmap and the Ordnance Survey. OpenStreetmap.org is the community-generated global map started by Steve Coast and subsequently a community of enthusiasts back in 2004 who wanted to map initially the UK, but in recent years and through a lot of humanitarian effort, the world. OpenStreetmap is actually plumbed directly into the FME Data Inspector, as we just saw, through the background map. Web services from Stamen Maps do that for us. It allows us to inspect our data more easily as we process it. But there's also a native OpenStreetmap reader that allows you to read and process pre-downloaded OpenStreetmap data using FME Workbench to whichever system you want to store it in, along with a custom transformer called the OSM downloader that allows you to grab it directly. We can have a quick look at reading OpenStreetmap data with FME now. So let's just do that. And it's nice and simple. If we go and just add a new reader to our process here, we can go and look in the catalogue of readers in FME, and we can see we've got an OpenStreetmap one, and we're just going to grab a little bit of OSM data and just consume it into Workbench. And all I'm going to do here is just filter it on the layers that are included in that data set. So in order to do that, I'm just going to group it by an attribute called FME feature type, which is just the layer that the layer name that is stored in that OSM data set. And that OSM format is effectively another form of XML data that we're consuming with a dedicated reader that allows us to see the content in its spatial glory. So that's going to pipe its way through. It's a pretty big data set, lots of content tucked away in there. And as I said, it's all community generated, so we'll be able to see tags on each individual feature that shows us who was the individual that actually went and created the data set or the feature. So if we zoom in, this is the centre of Cambridge, and we can zoom in on a particular location. You see there's a building there that I can click on, and you won't be surprised to know that because we're in Cambridge, there's quite a lot of university buildings, and I've happened to hit on the anatomy building in Downing Street. So there's a bit of metadata about the building type, how it was captured, who it's associated with, what the address is. And this is all metadata stored on that feature, created by a user called Confused Buffalo. So lots of data that's been captured there. So you might then want to potentially filter out of that data set anything to do with, say, highway features. So you can see in this particular snippet there's over 2,000, nearly 3,000 features that are something to do with the road network, and in fact footpaths as well, because those are footpaths there going through one of the municipal parks in the centre of Cambridge. So just a little bit about OpenStreetmap for you. With respect to Ordnance Survey data, though, many people use FME to process Ordnance Survey data for their own use. For example, the OS MasterMap Highways network is the road routing and path network for Great Britain. It supersedes the Integrated Transport Network, or ITN, and really I'm only mentioning it here because it's the first Ordnance Survey product that the OS have provided FME workspaces for processing it directly on their GitHub site. So you can download an FMW or an FME workspace to help you process the highways data. The MasterMap topography layer is also the most well-known large-scale dataset that people generally want to be able to load into their databases or GIS to be able to display their asset data on top of or capture boundary extents from. We've just assisted one of our local authority customers to translate MasterMap into a format that their highways team can use, for example, to display their traffic regulation orders against. But increasingly, OS data might be accessible from a web service rather than from a supplied set of files, and the OS Maps API is the advent of that capability. And to that end, we've recently been helping some of our clients look at what the options are to consume Ordnance Survey data as a service using tools built in FME. Changing tack then to look at web-based data for a minute, and the transport sector these days consumes a lot of data from the web. Whether it's vehicle tracking data from a fleet of buses, traffic count data from sensor loops buried under rubber strips in the road, or live feeds of push bike or scooter availability in a city operating an electric transport scheme. Data such as this offers a huge amount of intelligence about how we move around our transport network, and we want to be able to access it and analyze it. The Uber API is directly accessible via FME, so if you fancy taking a look at your recent taxi journeys to see if your world is starting to get a little bit bigger after not travelling very much in the last 18 months, you can give that a go with a web connection that's been created for you and is available to download from hub.safe.com, the community sharing site for FME. Alternatively, there's starting to be some really interesting content surfacing around last mile transportation on vehicles like electric scooters and cycles available on rental and sharing schemes. Bike Share Map is a fun place to go if you're travelling to a new place on a trip and want to know what transport options you might have when you get there. And certain cities have deals with companies like Cardiff and Nextbike that was recently rebranded by OVO Energy. Let's have a quick look at their Cardiff cycle racks, and then we'll have a go at consuming that data with FME as well. So if I just go to Bike Share Map, you can see, if that opens up for me, that we've got a little web map, and it shows you some of the bike sharing schemes that are around the country, and indeed around the world. But if I just go and have a quick look at Cardiff, I can click on Cardiff, and you could see there that there's 98 docking stations in Cardiff. And if I hover over them, you can see a little bit of detail and how many bikes and what spaces are available. And it's all sort of created as this little chart to give you an indication of how many bikes are stored at that location. So it's a pretty cool little site to have a play around with. We can also go directly to Nextbike's own website, which we can do, if that's going to open up. There we go, and it turned up. So you can see here that we're in Cardiff Bay, and you can see again another interface that shows you a pin on the map to show you that there's 3 bikes available at these locations, and in some cases there are references to the individual bikes that are left around the city. So so there's the Nextbike site, but let's go and have a crack at processing that data with FME, because we can. So in order to do this, I have a little pre-configured workspace. Again, we're going direct to the API, so the Nextbike live data feed, you can see here that it says nextbike-live.xml, so we're going to grab that. I'm going to run this because it takes a little while, because I'm actually going to grab all the data for the entire world for Nextbike. And you can see that it pulls that feed directly, grabs all of the bike rack locations, sets the coordinate system to lat long because it's a global data set, creates points on the map, and then what I'm doing here is I'm filtering the data. So I'm basically saying when the bikes field has got a value greater or equal to 5, then make those bike racks green, because they're the ones that have got more bikes at them. So if I'm going to set out to go and go to a bike rack, I want to go to one that's got a chance of having a bike at it when I get there. So that's all we're doing there. We're just doing a little bit of sort of stylistic data processing to be able to sort of give us an indication of what we want. And you can see here that we've got a smaller number of racks that have got more than 5 bikes at each of them. So that'll pipe its way through, and then we'll be able to take a look at the content that's come out from that site. So here we go. Okay, so there's our data, and if I zoom in, now I could put a background map on, but I sort of know the shape of the countries. It looks a bit like Europe. There we go, there's our background map. There's the UK. If I zoom in on Cardiff again, down here in South Wales, there's Cardiff, and if I make my background map a little less prominent, you can hopefully see that we've got lots of red, but we also have a few green rack locations. If we go and have a look, that we can see in here that we've got a rack here where there's exactly 5 bikes available for hire at that location. So really simple workspace, going to the internet and grabbing some content for us in this in this particular process. Private transport data also has a huge value though, and in addition to some of those sort of more public transport modes and infrastructure data that we've made reference to so far, the amount of sensors and cameras that are being developed to be on board autonomous vehicles will start to make a real impact on how we travel in the future. Apart from the fact that we're starting to drive around large data collection devices, frankly, with AI sensing signage and road surface quality in order to adjust the speed of our vehicle and reaction of the vehicle. Smarter roads are also more of an innovation, like the work on the M42 in the West Midlands, will mean that we can expect to have more data about trends in travel at different times of day or the week or even the year. Of course, individual vehicle tracking data will likely be tightly protected because it's got a commercial value, but many fleet tracking solutions like Masternaut already have APIs that we can connect to with FME to allow us to trigger geofence alerts if vehicles go somewhere they shouldn't, or if we just want to put the vehicle position data into a system that we need FME's rich format support to be able to load. And of course, if you've got a fancy car yourself, you may have access to your own data that you'd like to play with using an FME home use license, for example. Anyway, just as a quick last example, I wanted to draw the session to a close by showing you an FME Server Workspace app. This is a very simple app that can be put together by selecting options from a toolkit in either FME Server or FME Cloud, and importantly, you don't need to be a web developer to build an app like this. You get an interface to do it. A Workspace app is effectively a pretty front end to a traditional FME process, and it allows you to do something with your data by calling a workspace behind the scenes. In essence, you can hide the complexity of the process behind some parameters that someone can use without having to know how to use FME or even what FME is. Here's an example that uses the traveltime.com web service to calculate the achievable distance to travel in a specific time from a specific location. Let me show you what I mean. So here's the app. It's a hosted app on our FME server instance, and effectively what I can do is I can generate isochrones or travel time zones around a point of interest. So I'm going to go to Bath, and if I zoom in to the rail network, you can see there's a station there called Oldfield Park, and let's say I want to identify a location or a travel time from that point, and I want to travel, well, ideally we'll go in the future rather than the past. So it's the 26th today, let's travel tomorrow, and we want to travel around peak, evening peak, and we want 15-minute isochrone bands, and we're going to sort of go on, give that a run. Now what this is going to do is actually going to stream the answer back into a web page, so we can go and see how far we could travel from that point, and in this case by driving. So we've put the stats. We've got 15-minute time bands here, so obviously in the first 15 minutes we can't get very far, but we can get further up the A4 here because it's a bit more of a significant road that'll get us out of the city more quickly. The next 15 minutes, generally we can get sort of roughly in all directions about the same speed, a bit more of a ability to get a little bit further up the A4 here, but you can see the sort of extents. So in an hour we could very nearly get over the bridge and into Wales to Newport, but not quite in the evening peak. So just a little example of, you know, using an app, having FME behind the scenes, getting the ability for somebody who doesn't know how to use FME necessarily to go and run a process and get the answer to a question that they might have. So hopefully then, as you can see, by implementing a data integration solution such as FME, you can make sure your data is connected across systems, teams and applications. And now you've seen a little of what you can do with FME in the context of the transportation sector, you might be interested in finding out a little bit more about the costs associated with an FME solution, or perhaps where and how you can deploy it to help you. If you are, then by all means get in touch with us at fme@onespatial.com, and we can tell you about the types of subscription that are available, or how you can cost effectively buy just 1 or 2 licenses. FME also has a number of platforms onto which you can deploy it, and there is scope for some short-term pay-as-you-go style options with some of the enterprise solutions as well. Or maybe you'd like to do a little bit of your own research first, or perhaps you're already a user and you just want to learn some new skills. Well, to find out what training we offer, what other FME webinars are coming up, or if you just want to dig into some of the hours of material that we have recorded and hosted on our on-demand pages on onespatial.com, just follow some of these short URLs to get a little more detail, or reach out to us at fme@onespatial.com for some help or a quotation. Alternatively, a URL you mustn't forget is community.safe.com, because that's where all the tutorials and how-to articles are located, including the chat forum where you can ask thousands of FME users what their experience is with a specific challenge you might have. If you're already a customer of ours though, or on active maintenance and support, then you can access our priority service, and that is via support@onespatial.com. If you're not sure though what the status is of your existing FME license estate, just drop Charlie a note either now in the chat or after the session, and she'll let you know what you're entitled to. So her email address is down in the bottom left hand corner there. And there we go, that's it for today. Thank you very much for joining us live, and I'm really grateful for you to come along. We hope you enjoyed the session, and we hope you'll join us again at the next session on the 4th of November. Just go to onespatial.com/events to find out what the topic is and register. Thanks a lot.